so for this one, I'm going to be doing a lot of erasing and drawing and erasing, so bear with me. So first off, as I told you in class, let's put the C up here to make it more obvious that is that point right there at the top. Okay, so a chord. There are a lot of choices for chords. A chord goes from one point on a circle to another, so that is a chord. Technically, GF is a chord. And the diameter is also a chord. So you could use any of those you want to name these. Now when you're naming a chord, remember, you put a little line segment above it. So CD, GF. If you wanted to put the diameter, you could, but there you go. Now, radius. Radius is going to be from the center out to the edge of the circle. So HE, HC, or HF. Any one of those counts as a radius. And you only need one of these. I'm just trying to show you so you understand any one of those could count as a radius. Diameter. As stated before, that would have to be only one choice, and that would be CF. Central angle. That has to have H in the middle. Okay? So any angle with H in the middle, such as FHE. And remember, you put the symbol, so that's angle HFE. And the center, nope, I just wrote what I was going to say incorrectly. FHE. The center H must be the middle letter. Another one would be CHE. That's another central angle. So angle CHE. Just for example. Inscribed angle. An inscribed angle has all points on the circle. So that is an inscribed angle. DCF. Another one would be GFC. Those are both inscribed angles. And again, remember, you're going to put the angle mark and DCF. And if you put FCD, that's okay. You could have also maybe seen this one, GFC or CFG. Major arc. Lots of these. Pick any point and just go. So let's start at B. Now you have to go more than halfway around the circle. So halfway would be about there. So just make sure you go to E. Or D. It makes no difference. Okay? Better to go further than less. And now pick any three letters, well basically B and D, and anything in the middle. That's all that matters. So a major arc, remember you're going to use three letters, you're going to put an arc mark. So B is definitely going to be on there, and D, and pick any letter. G, F, or E, it doesn't matter. Okay. That's one. Again, anywhere you want to start. Let's say you want to start at C, because you can definitely see the half circle. That's a semicircle. Just keep going. And then write down an arc mark, and you're going to have three letters. Starting at C, ending at E, and you can use either F or G. It makes no difference. Those are major arcs. A minor arc is going to only have two letters, and it's got to be less than a semicircle. DE, GF, BC. Those are all minor arcs. Okay? So again, you're going to put an arc mark and just use the two letters, BC or GF. or DE. All those are minor arcs. Semicircle, already mentioned that. And the most obvious one to do, because you have 2 points C and F that are opposite each other, would be to go this way, or you could go this way. It makes no difference. You just got to use 3 letters for it because semicircle is a major arc. So C ending at F, and you can put either the B or the G there. Doesn't matter. And again, C ending at F, and you can put either the E or the D. Makes no difference. Those are your semicircles. A secant. A secant goes through the circle. So the only one we really have here is that one right there. And you only need 2 letters for that. So FA. And since it's going on forever, make sure you put arrows in that border. And then the tangent is going to be AC. And since this is going on forever, you know, you can put arrows there. All right? Okay, the measure. All those little M's mean measure. KO. KO is right here. Well, when that happens. That's KO. All right? 2 letters means, and remember, pay attention to the symbols. This is an arc. This is an arc. This is an arc. 13 and 14 are angles. Pay attention to that. Now, 11 only has 2 letters. That means it's in a minor arc. D. MLN is either a major arc or a semicircle. So we have to look at it. Starting at M, going towards L, and around to N. Well, that's more than a semicircle, so that is C, a major arc. And then K and L, starting at K, going towards N and around to L, that is also going to be a major arc. All right? Now, we don't have any semicircles, but if we had KLM, that would be a semicircle. Or KNM, that would be a semicircle. Or NML, or NOL. Those will all be semicircles. But we don't have any semicircles here in this setup of the problem. And then OMN. So we're at O, and we're going to M, and we're coming back to N. That is an inscribed angle, B. And then MON, starting at M, going to O, and going to N, also inside the circle, so that is B. Now, notice we don't have any central angles, A. But for example, central angle would be OPF, NPM, something like that. Those would be central angles. Now, let's do the math. First off, 60 plus 80 is 140, which means this angle right here needs to make that semicircle, so that's 40 degrees right there. Now going this semicircle, 60 plus 40 is 100, which means this is 80. And again, since this is a semicircle, this is 100. There's all my numbers that I need. So KO is 40. MLN is 80. plus 60 plus 40 plus 80. That's 260 degrees. I'm going to skip down to 15, K and L. Again, starting at K to N, that's 80, plus 100, plus 80. And that ends up being 260 also. All right, OMN. Again, O to M to N. So we're looking at this arc right here. That's going to be 80 plus 40, which is 120. But remember, for inscribed angles, we divide by 2, so that's 60 degrees. All right, now for MON. M to the O to the N. Well, that's this right here. So that's 100 degrees. Divide by 2, or 50. Inscribed angles we divide by 2. Moving on. Again, this right here is a semicircle. So therefore, 130 plus 50 makes 180. This right here is a semicircle. So 50 plus 50 is 100, which makes this 80. And again, 50 plus 80, right here, this is a semicircle. 50 plus 80 is 130, or we have 130 right there. So that's 50 also. So lots of 50s. Whoops. Didn't mean to do that. Okay. So, QU. Again, you might want to go through and mark off, arc, oh, this won't help. Angle, let's use a G. Angle, let's use a G. Angle, arc, angle, arc. Just to remind yourself what you're looking for. Now, QU is an arc. So we're talking about this right here. That's 50 degrees. (17) KCU. KCU. You're going to have 130 plus 50 plus 50. That's going to be 230 degrees. Now, angle, QLU. So going from Q to L to U, that's a central angle. So that's going to be 50 degrees. KUI. So K to U to I. That's all about this right here. So we're at 1550, and it's 100. And remember, we do 100 divided by 2, because it's an inscribed angle, to get 50 degrees. ILQ. Going from I to L to Q. That's a semicircle. Okay. Well, it's a 180 degree angle because we're doing the angle here. It'd be the same for the arc. It goes I and UQ. Then QC. QC, and it's an arc, so we're going on the outside here. 80 plus 50, that's 130 degrees. IUK. That's an angle. So we're starting at I, going to U, and going to K. That's this right here. That's 100 degrees. Again, oh, sorry. That's the arc. So that's 100. I wasn't paying attention to my own stuff, so I didn't listen to myself. Sorry. I'm messing this all up. This is 80. So we're doing not an inscribed angle, it is an arc. I pay attention to my own hints. So it's an arc going from I to U to K. So we're adding 130 plus 50 plus 80, so that makes it 260 degrees. So you can see how easy it is to make a mistake, even when you know what you're doing, and you have little hints here. It's still possible to screw up, so just be careful. QLC, I want to reiterate to myself, it's an angle. QLC, so from Q to L to C, that's a central angle, 80 plus 50, 130 degrees. KIU. KIU is an angle, starting at K, going to I, going to U. That is an inscribed angle, talking about this right here. So 80 plus 50 is 130, divided by 2, 65 degrees. KUI. KUI is an angle. So we're going from K to U to I. 50 plus 50 is 100. Divided by 2, so 50. Angle, CQI. So going from C to Q to I. Right here, that's going to be 50 divided by 2, or 25 degrees. And last but not least, measure of CL, and it is an arc. So CL, just going from here to here, that's going to be 50 degrees. All right. Let's do some number crunching. So this is an inscribed angle here. This is going to be half of 150. So you can just do it in your head and say 6x minus 24 equals, you could technically write out, the formal way to do this would be to write out 1/2 of 150, or you can just go right to 75. You add 24, you get 99, and if you divide by 6, x is equal to 16.5. Some of these numbers work out nicely, some don't. Okay, right here, these add up to 180. So x plus 130 equals 180. You can kind of do it in your head. Subtract 130, you get 50. Here, 2x minus 5 is the central angle, is equal to 75 degrees. 2x equals 80. When you add 5, divide by 2, x is 40. Hit pause if you need it. Again, an inscribed angle, so half of 100, whoops. Half of 100 is 50, so 3x minus 17. You can just go right to it and write 50 if you want. Add 17, 3x equals 67. Divide by 3, and you get x is equal to 22.3, repeating. What we have here is vertical angles. So 6x minus 20 equals 40. Set them equal to each other. Add 20, we get 6x equals 60. Divide by 6, x is 10. Now, all three of these, 5x minus 10, plus 2x, plus 2x minus 2, all equal 360. I'm going to join like terms. That's going to give me 9x. Negative 10 minus 2 is going to be minus 12. I'm going to add 12 to both sides. I'm going to get 372. And when I divide by 9, I get 41.3 repeating. All right. These inscribed angles are both touching the same arc right there, IP. Since they're both touching the same arc, this angle and that angle are congruent. So 4x plus 9 is equal to 6x. Subtract 2x. Subtract 4x to get 2x equals 9. Divide by 2, x equals 4.5. Alright, here we know the radius is 13. We can draw in another radius right here, 13. Right angle, that's the hypotenuse. So x and 5 are my legs. So x squared plus 5 squared equals 13 squared. Good old Pythagoras. So x squared plus 25 equals 169. Subtract 25, and I get 144. Square root, I get 12. All right, this is the formula off your card. In this situation, you take 4x minus x divided by 2 to get the angle. But this time we already know the angle. We don't know the arcs. So we just fill it out that way. And we want to get rid of the 2. So we're going to multiply by 2. 4x minus x is 3x. The 2's cancel. I get 50. I divide by 3. And I get 16.6 repeating. Same situation. 120 minus 10 divided by 2 equals 5x. So 120 minus 10 is 110. Divided by 2 is 55. I could also multiply both sides by 2, but there's really no reason to since I don't have an x in there. So that gives me x equals 11. Alright, since this goes straight through, x is in between them. I can just do my formula of 145 plus 45 divided by 2 equals x. Which will give me, once I crunch my numbers, 95. Right. Right angle here. This is 9, this is 8, which makes this 17, which is my hypotenuse. So x squared plus 8 squared equals 17 squared. So the tangent forms a right angle with the radius there. So that gives me x squared equals 225. 17 squared minus 8 squared. So x is 15. All right, so I need to find the measurement of that little piece right there. I'm going to add 50 plus 120 plus 150. So this will be 320. Subtract that from 360 to give me 40. That means this is 40 right here. Now I just do the math. 120 minus 40 divided by 2 is equal to x. That's 80 divided by 2, so x is 40. Radius is 15. Oh, remember I told you that I had to change it to 16? Okay, so this is 16. This piece is 30, which means this is 15 and this is 15. I don't know x. So I'm going to do x squared plus 15 squared equal to 16 squared. Alright? So I'm going to do 16 squared and then subtract 15 squared, which gives me x squared equals 31. Take the square root of that, and I get x equals 5.6. Alright. So, circumference is equal to pi times diameter, or 2 pi r. So, this is actually pretty easy. 18 is this line right here. Well, guess what? That's also the diameter. It's also has a radius of 9. It says leave in terms of pi, so literally all I have to do is put 18 right here, or 9 right there. And what's 2 times 9? 18 pi. Okay, find the arc length for ACB. This is what I was talking about in class where I messed up on the quiz. It says ACB, major arc. So we don't want to use 65. We need the 295. And that's what I was thinking about when I did that. Okay? So pay attention to the details. We're looking for the major arc. So we're going to do two things. We're going to do 295 over 360. The central angle over 360, both times. And this formula is on your cards, on your sheets. So remember, the radius is 3, that's important. So we're going to do the arc length first. So all we put here is 2 times 3.14 times the radius. And right here, this is just the circumference formula, 2 pi r, which we just talked about over here. So you just take the central angle divided by 360 times the circumference formula to get the arc length. And we end up with 15.44. Now, to find the area of the sector, we're going to take central angle divided by 360 times the area formula, pi r squared. Now when you crunch those numbers, you end up with 23.16. All right, here we go. Determine if it's tangent or not. This must be a right angle. So 5 squared plus 12 squared must equal, wait, not 8 squared, this is 5, so that's 13, 13 squared. Well, that leads to 169 equals 169, so the answer is yes. The line is tangent. Here, again, we try 8 squared plus 15 squared, and see if it equals 17 squared, and magically, it does. So the answer is yes, that line is a tangent. This is 8, which makes this 10. This is going to be my right angle, so that's going to be my hypotenuse. So 6 squared plus 8 squared should be equal to 10 squared if it is a tangent. Well, 36 plus 64, 100 equals 100. And you might be second guessing yourself, thinking they can't all be yes, but they were. Change any one of those numbers in that any of those problems, and it would have been no. All right. All we're doing, remember here, is doing those two multiplied equal those two multiplied. So 2x times x is 2x squared equals 6 times 58, which is 348. Divide by 2, and you get 174. Take the square root of both sides, and x is equal to approximately 13.2. All right. So, remember, we need totals. This is x plus 9. This is 18. Always want totals. And remember the formula. It's outer times the total equals outer times the total. So it's going to be 9x plus 81 equals 180. Subtract 81, 9x equals 99. Divide by 9, x is 11. When the point comes from outside and hits both, the circle is both tangents, then these two are just equal to each other. 6x plus 8 equals 19. Subtract 8 and you get 11. Divide by 6 and you just get the simple fraction 11/6. or if you did it as a decimal, you get 1.8. All right, remember, we always want the total. So 12 minus 8 is 4, so this whole thing is x plus 4. Now this one is a different formula. This is outside times whole equals the tangent squared. So I get 12x plus 48 equals 2304. I'm going to subtract 48 to get 2256. Divide by 12, and I get 188. All right. Now, if the x was over here, we just divide 145 by 2. But it's not. It's over on the other side. So I need to find out what this is. Well, it's going to be 360 minus 145. So that's going to be 215. So this is 215 degrees. Divide that by 2, and we get 107.5. So be careful. Don't just divide the number you see by 2. Make sure the arc is on the same side as the angle you're looking for. Okay, so number 52. If this whole thing is 16 and this is 10, that makes this 6. So now I can do outside times whole equals outside times whole. So that's going to be 12x is equal to 96. Divide by 12, and x is 8. All right. Again, these are on your cards. When you're converting into radians, you're going to multiply by pi over 180. Now remember, I showed you a little trick. You can use your handy-dandy calculator here. And if you hit alpha y equals, and just hit enter, you can put in 195, go down, put 180, enter, and it tells you that's 13/12 produced. So you can just write 13/12, and then put your pi and write radians. Right? You can even abbreviate to rad. That's okay. So let's see, you're going to do pi over 180. You go to your calculator, do the same little trick, and you're going to get 5/4. My bad. That wouldn't make sense. 3/4. 5/4 pi radians. Now this one we got to get rid of the pi. So pi is going to go on the bottom, and 180 is going to go on the top. So remember, the pi is going to cancel. And again, you can just take your calculator and do that same trick. And you can actually do the math right here. You can type in 17 times 180. Go down. Put 18. And there you go. 170 degrees. Again, the pi's cancel. You can even do it in your head. 6 goes into 18 3 times. So 180 30 times. And 30 times 5, 150 degrees. All right, so remember the trick on this one. Okay? We're doing final over start. So pay attention to what we're doing. We're going from A to B. Think about it. A to B. A is getting smaller to become B. So my radius is 1, 2, 3. My radius here is 1, 2. So right off the bat, final, we're getting smaller. Final radius on top, beginning one on the bottom, 2/3. And 2/3 will make it smaller. 3/2 will make it bigger. Because 3/2 is 1.5 times. That makes it bigger. Now, going from A, we're going X first. So we're going 1, 2, 3, 4. That's -4. And then we're going down 1, 2, 3, 4, 5, 6, 7. Down 7. Remember, this is just basically x comma y. How we're moving. Left 4, down 7. All right. A, radius is 1. B, radius is 2. We're going from A to B, so we're getting bigger, so that's 2 over 1, or just 2. Translation. From A, we're going right 1. And we're going up 1, 2. Sorry. 1, 2, 3. And that's my vector right there. Right 1, up 3. And here we are at the very end. It says, the diameter of the outside circle, the big circle, is 22. The diameter is 22. Which means the radius is 11. It says the diameter of the inside circle is 13. Which means the radius is going to be 6.5. So to make your life easier, remember, the radius here is 11, and the radius here is 6.5. So we're going to do the area of the big, pi r squared minus pi r squared. That's simple. Big minus the small. So that's going to be 3.14 times 11 squared minus 3.14 times 6.5 squared. That's all we're doing. So that gives us 379.94 minus 132.67, which gives us an overall 247.27 square inches. And that's it.